This is question 1 from the Socrative, and I'm going to do it as if it were an open-ended question so you can see all the work that is necessary to do. The question wants to know where this graph of f of x is concave up. And what I know is that a graph is concave up when its second derivative is positive. So I have to first find the second derivative. What I'm eventually going to do with the second derivative is a sign chart for it, and in order to get the numbers on the sign chart, I need to know where the second derivative equals 0. What I'm doing is I'm finding the critical points of f prime. When I look at my second derivative, I see that I have a common factor of 4x that I'm going to factor out. And that leaves this trinomial, which then factors again into x minus 6x plus 3. The zeros of this are going to be 0, 6, and negative 3. These are the three numbers that belong on the sign chart. I just have to make sure I put them in the correct order that they would fall on a number line. I've got 4 intervals to test, from negative infinity to negative 3, from negative 3 to 0, 0 to 6, and 6 to infinity. And I'm going to test it in the factored version of f double prime, which is this one. Because I don't care what the actual number is, I'm just doing a sign analysis. All I need to know is positive or negative for f double prime, and that will tell me what I need to know. On this first interval from negative infinity to negative 3, just pick any number like negative 10, and I'm going to substitute it into each one of these factors. 4 times negative 10 is a negative. Negative 10 minus 6 is a negative. Negative 10 plus 3 is a negative, so I'm multiplying 3 negatives together, which in the end is going to give me that negative. Pick a number between negative 3 and 0, like a negative 2. Negative 2 times 4 is a negative. Negative 2 minus 6 is a negative. Negative 2 plus 3 is a positive. So I have a negative times a negative times a positive. And the net result there will be a positive. I just do the same thing on the remaining 2 intervals. On the interval from 0 to 6, it's a positive times a negative times a positive. And that gives me a negative. And when I pick a number greater than 6 and put it into my factored form of f double prime, I see everything is positive. I've already decided I'm looking where f double prime is positive, and I see that it's happening on 2 intervals from negative 3 to 0 and 6 to infinity. So I can see right away my answers are B and D. If you were doing this as an open-ended question, you would need to summarize this in a separate statement. And I do that right here. So the important parts of this, if you're answering this open-ended, is you must show the first derivative, you must show the second derivative, you must have it equal to 0. Show your critical points of f prime, the 0, 6, negative 3. No one's going to look at this sign chart. That's for you to organize your information. And you must take the information your sign chart's telling you and summarize it in a statement. And in that statement, you have to give the intervals, which I've done here, the negative 3 to 0 and the 6 to infinity, along with your reason. And that's just as simple as saying f double prime is greater than 0. In question number 2 on the Socrative, the question is we want to know where f is concave down, and we're given a function for f, and it's got an exponential in it. The knowledge that I need is that f is concave down when its second derivative is negative. Similar to question number 1, I'm going to have to do a sign chart for f double prime, and to get the numbers on my sign chart, I do my second derivative and set it equal to 0. Here's my first derivative, which is a product rule, and I'm treating 2x as my first factor and e to the x as my second. First times derivative of the second plus the second times derivative of the first. To get to the second derivative, I have to do another derivative. It's going to involve another product rule on this first term. It looks like this. First times derivative of e to the x is e to the x, plus the second as is times derivative of 2x, which is 2. This plus here is this plus here. The derivative of e to the x times 2 is just the same thing, so just 2e to the x. That leaves me with 3 terms. They all have a 2 that I can factor out, and they all have an e to the x that I can factor out. Factoring 2e to the x out of this first term is just going to leave the x. Factoring a 2e to the x out of that second term takes everything out, so I'm left with the 1, and ditto for that third term. 1 plus 1 is this x plus 2. I also want to make sure I set this equal to 0. That's how I'm finding those critical points of f prime. When I set this equation equal to 0, I need one of these factors to equal 0. This e to the x will never equal 0. No matter what x is, this will always be a positive number. The only place that I'm going to get a 0 is this x plus 2 factor. That's going to give me an x equals negative 2 is a 0. That negative 2 goes on my sign chart, and this is the sign chart for f double prime, because the sign of f double prime will tell me where f is concave down. I pick a number from each test interval. My first interval is less than negative 2. I would pick something like negative 3, and I would put it into my factored form of f double prime. That's this guy right here. Like we said before, no matter what I put in for this e to the x, it's going to be positive. If I put a negative number here and add 2, it's going to be negative. So this positive out here times the negative in the parentheses is going to give me a negative on this interval. When I put a number greater than 2, like for instance a 0 in for my x's, a 0 in for this x, e to the 0 would be positive times a positive 2. This is all positive. And a 0 plus 2, that factor is going to be positive as well. So my net result is a positive. And I decided at the beginning of the problem I wanted where f double prime was less than 0. And I see that that's happening right here on that interval where x is less than negative 2. That's enough to help me identify my answer in the multiple choice. If this were free response, I would want to take that answer and write a statement for it. I would need to make this statement that f is concave down on that interval from negative infinity to negative 2 because f double prime is less than 0. In Socrative question number 3, we're asked to find points of inflection on the graph of f, and we're given f double prime, which means we don't need to do any derivatives. It's already done for us. What we know about points of inflection are they occur where f double prime equals 0 and changes sign. That sign change is important. If there's not a sign change, it doesn't signify a change in concavity, and that's what a point of inflection on f is. I'm going to first set that f double prime equal to 0, which gives me 3 values, 0, 3, and 6. At this point, they are possible points of inflection because they meet the first requirement of being equal to 0, but now I have to check out that second requirement of the sign change. And what's going to do that is a sign chart. Here is my sign chart for f double prime. I put my 3 values on there in the order they would appear on a number line, 0, 3, and 6. I would pick a test number less than 0, such as negative 1. I would put it into my f double prime. When I put a negative 1 into that x and square it, it's going to go positive. A negative number in here and subtract 3 is a negative. A negative number subtract 6 is a negative as well. I get a positive times a negative times another negative, and the net result is a positive on that interval. When I pick a number between 0 and 3, such as 2, and I do the same thing, when I do 2 squared, I get a positive. 2 minus 3 is a negative. 2 minus 6 is a negative. And I end up with the same exact sign, positive times negative, that I did on the previous interval. What that's telling me is that 0 is not a point of inflection because although f double prime does equal 0, I do not undergo the sign change because it's positive on the left and it's also positive on the right. So 0 is not a point of inflection. When I pick a number in between the 3 and the 6, like a 4, and I run it through my f double prime, I get a negative value. And when I pick a number greater than 6 and do the same thing, I'm going to get a positive. What I see is that I do undergo a sign change at the 3 and at the 6. At 3, f double prime goes positive to negative, and across the 6, f double prime goes negative to positive. That indicates that these truly are points of inflection. That's enough for me to identify D is my correct answer. My points of inflection are 3 and 6 only. If this were on an open-ended question and you had to show work, you'd want to sum it up in a statement similar to this. Point of inflection at x equals 3 and 6 because f double prime equals 0 and changes sign. Our last Socrative question gives us an f of x function and asks where that function is decreasing and also concave down at the same time. So I have two requirements to find. We know f is decreasing when f prime is less than 0, and we know that f is concave down when f double prime is less than 0. Let's start by finding where f is decreasing and doing a sign chart for f prime. Here is my process for finding those numbers that go on my sign chart. Here's my first derivative. Set that equal to 0. That's how I get the numbers to go on my sign chart. Factor out my 8x. I'm left with x squared minus 9, which is the difference of two squares, x plus 3 and x minus 3. Gives me three numbers for my sign chart, 0, -3, and 3. I handle this sign chart just like I did the previous one, so I'm going to use this factored form of f prime. Pick a number less than -3 and run it through here, see if we get a positive or negative result. What we end up getting on this interval is a negative. Between -3 and 0, when I put my test number in, I get a positive in here. In between the 0 and the 3, pick a number like 2 and test it in your factored form. You're going to get a negative. And greater than 3, everything will go positive and give us a positive result. My decreasing intervals are where this f prime is negative. My sign chart is telling me that's happening less than -3 and between 0 and 3. Let me go on and look at this part. So now I have to look where f is concave down, and that's going to involve the second derivative. Here is the derivative of f prime. Another power rule, 24x squared minus 72. Again, I need to set that equal to 0. I factor out a 24. I'm left with x squared minus 3. I set that factor equal to 0. I solve, and I get two values to put on my f double prime sign chart, positive square root of 3 and negative square root of 3. When I do this sign chart, I'm going to line it up vertically with my f prime sign chart. I'm going to put that square root of 3 and negative square root of 3 where they belong. So negative square root of 3 is somewhere in between here. My positive square root of 3 is somewhere in between here. So I'm going to pay attention to my f prime sign chart when I'm making my f double prime sign chart. I go through finding where f double prime is positive or negative just like I did before. I'm going to use the factored form here. I pick a number less than square root of 3, and when I put it in here, I can see I'm going to get a positive on this interval. I pick a number between negative square root of 3 and positive square root of 3, like 0. When I put 0 into my factored form, I get a negative value. A number greater than square root of 3 turns everything positive, and I'm going to get a positive. I can see f double prime is negative here in between negative square root of 3 and positive square root of 3. So that's where f is concave down. To find where both of these are happening, I need to consider both of these sign charts together. I have the yellow highlighted are the intervals I'm interested in, and I'm looking for where they're both occurring. I can see in this part right here, I'm meeting that requirement for f prime, but not for f double prime because I'm not highlighted here. And here, they're both positive in this region. Once I move past this negative square root of 3, now my f prime is positive, but my f double prime is negative. But once I move past 0, I can see they're both negative because they're both highlighted yellow in here until I get to this square root of 3, and then the f double prime isn't negative anymore. So this interval where they were both negative, which is right in here, is what's going to answer my question, and that's going to go from 0 to square root of 3. So my answer is C, the interval from 0 to square root of 3. My sign chart is enough to identify the answer, but it's not enough to justify my answer. So I would need to go and make a separate statement as to why I chose that interval. So f is decreasing and concave down on my interval 0 to square root of 3 because f prime is less than 0 and f double prime is less than 0. And that's enough to justify my answer. So multiple choice, nobody's looking for your justifications, but on open-ended, you would want to make sure that you sum everything up in a statement like this one.